Awesome. So thank you so much for those of you who are joining us today. Thank you again. My name is Jessica, and I am pleased to be your host for today's session, Get to Know Chemistry, as part of Ryerson's virtual open house, which is taking place this week, November 9th to 13th, as well as next week, November 16th to 20th. There are many different sessions that are taking place across these 2 weeks, so we encourage you to visit our website and register for any other sessions that may interest you. To start, I would like to take a moment to acknowledge the land in which this university exists. Toronto is in the Dish with One Spoon territory. The Dish with One Spoon is a treaty between the Anishinaabe, Mississaugas, and Haudenosaunee that bound them to share the territory and protect the land. Subsequent Indigenous nations and peoples, Europeans, and all newcomers have been invited into this treaty in the spirit of peace, friendship, and respect. Now, Ryerson has shifted to an essential services model to help prevent the spread of COVID-19, which is why we are with you on your screens today and not with you in person. We have put together a series of virtual sessions in order to share information and connect with you as potential students. Ryerson is working diligently to provide students with fulsome experiences while maintaining the health and safety of our community. Now, for those of you who maybe have been living on Zoom like us for the last couple months, and maybe those of you who are maybe new to this platform, we encourage you to ask questions. We have many faculty and staff members who are here today behind the scenes to help answer your questions. So to do this, please feel free to scroll down or move your mouse to the bottom of your screen to the Q&A pod. This is where you can ask questions throughout the session, as well as let us know if you happen to have any visual or audio issues. Please feel free to flag them in the Q&A pod so that we can hopefully help troubleshoot you to get the best experience, troubleshoot this to help you get the best experience as possible. You also may rearrange your screen in any way that works best for you. Anything that you do to your screen will not affect ours. So feel free to make it bigger, smaller, or move things around however you see fit. This presentation is also closed captioned to ensure accessibility. If you require closed captioning, please select that option at the bottom of your Zoom screen. And also note that the recordings of all virtual open house sessions will be available on our website later on as well. We'd like to get to know a little bit about those of you who are joining us as well. So I'm going to quickly launch one poll here to check in to see who is joining us today, whether it be prospective students or current students of university or colleges, parents, teachers, etc. I'm going to leave this up here for about 5 or 10 more seconds so that we can get a feel for who's joining us. Awesome. Thanks so much for those of you who looked up. I'll feel free to share those results with you quickly. So it looks like we have a lot of prospective students who are coming into our university next year. And those of you who are thinking about applying in the future, I hope that we can give you a lot of really great information and welcome to those parents and guardians as well. So without any further ado, I would like to introduce Dr. Stephen Wiley, who is our chemistry program director, to start the presentation and take over from here.
Thank you very much, Jessica. Okay, so let's get started by talking about what chemistry at Ryerson is going to be like. So I'll start with a brief overview of the presentation. First, we'll talk about admissions, and then we'll run through what the curriculum looks like. So a fairly detailed look at first, second, third, and fourth year. Then we'll talk about the minors, options that you have, the co-op program, opportunities at Ryerson, support that's available for you at the university, and postgraduate options. So this is where we're going in this presentation. So let's start by talking about the admission requirements. So for admission, you have to have an Ontario Secondary School diploma or equivalent with a minimum of 6 grade 12U courses. We require that you have English and ENG 4U is preferred. Advanced functions, so MH, F4U, and 2 out of the 3 sciences, chemistry, biology, and physics. Now, you're applying to the chemistry program, although chemistry isn't absolutely required, it's really strongly recommended. Ideally, you would have all 3 of these sciences if that's possible, because in your first year in the chemistry program, you will also be taking biology and physics. So If you have all three of them, then you have the best preparation you can have going into it, but you have to have at least two. And the minimum grade in the required courses varies from around 65 to 70% overall. And admission is based on your best 6 12U courses. Okay, so let's talk about the curriculum. First thing to know about the chemistry curriculum is that it reflects CSC accreditation. So the Canadian Society for Chemistry has a program where they accredit chemistry programs in universities across Canada and even outside of Canada. Accreditation is valuable because it provides for a sort of a national standard of chemistry education, so that all of the universities that have chemistry programs that are accredited are teaching according to a set of agreed upon standards. And it also promotes portability of qualifications for chemistry graduates. So if you wanted to start in a graduate program at a different university, they will recognize that your Ryerson chemistry degree meets the same standards as their own chemistry degree would. Chemistry traditionally has 5 subdisciplines, and you'll see these coming up when we talk about the different courses we take. So there's an analytical chemistry, essentially measurement, measuring amounts of materials. This shades over into things that you've encountered, probably like forensics and things like that. Biochemistry, so the chemistry of life. So this is really focused on the molecules that form the building blocks of life in systems. Inorganic chemistry, which is the chemistry, basically it's a vast chemistry of the periodic table, but organic chemistry really focuses on carbon and hydrogen based molecules, which are a very important and significant part of practical chemistry. So for example, drugs and dyes and materials and polymers and so on, all basically derive from organic molecules. And then physical chemistry is really the sort of a deeper understanding of chemistry from a mathematical and physical perspective. So the accreditation requires about 1,000 hours of chemistry, laboratory, and classroom work. And it has a requirement of a minimum of 400 hours in each. So this basically guarantees that your chemistry education is going to have a strong practical component. So let's look at first year chemistry. So this is really the year that sets the base for going forward. And it's also a common year that you share with biology and medical physics students. And it also is pretty similar to first year for biomedical science students as well. So you'll start in the fall with Gen Chem 1, with Biology 1. And you'll notice a little symbol there beside the BLG 143 that looks like a Bunsen beaker. That represents a practical component or a lab. So biology has a half lab, which means it has a lab that runs every other week. Physics also has a lab or a tutorial, so Physics 1, and Math 1, which has a tutorial, and programming, so computer programming, which you can either take introductory programming for scientists, which is CPS 118, or you can take CPS 109, which is Computer Science 1. And you might want to do that if you're interested in computer science and you want to take advanced computer science courses, because CPS 109 is a prerequisite for those. So that's the fall semester. Oh yes, and then there's also a 6th course that doesn't run every week, and it's largely delivered online, and that's SCI 180. So that's the orientation course, and what that does is it provides you with background information about how Ryerson works and how your degree program works, and it addresses a lot of things that are useful for students to know in their first year. Library resources, how to calculate your standing, pretty much everything that's connected somehow to your academic experience. In the winter semester, you take the second half of Gen Chem 2, and this has a full lab running every week for 3 hours. Biology 144, so Biology 2, again, with a half lab, so lab every other week. Physics 2, Modern Math 2, it says 1 there, but it should be 2, and a lower level liberal elective. So during the course of your degree, you'll take 6 liberal electives, and these are courses which provide breadth to your sort of understanding of society and the world, and they focus on writing skills. So you have to, the work that you get marked on is of a written format, sort of essay style. But you have a lot of choice in terms of what particular subjects you could study. You know, if you like history or English, psychology, in some psychology courses, sociology, that kind of thing. So a lot of choices, and you would pick your lower level liberal that you wanted to take going into before you went into the winter semester. Okay, so that's the overview of first year. And like I said at the start, it kind of sets the stage for what's to come after. Okay, so second year chemistry. This is when you start to really get into chemistry in a big way. So it starts with organic chemistry, which has a full lab, analytical chemistry, which has a full lab, physical chemistry, which doesn't have a full lab, which is probably a good thing. So those are your 3 chemistries. And then you also take an advanced math course, calculus and geometry, which is going to provide you with the tools you need, particularly for the physical chemistry, and a later course that deals with atomic and molecular properties. And then your second lower level liberal elective. In the winter, you take the successor course to Organic Chemistry 1, which is Organic Chemistry 2, Analytical 2, which has a full lab, Physical Chemistry 2, which has a full lab, and Biochemistry, which also has a full lab. So by the time you get to the winter, you've got a lot going on in the laboratory department. And then your third lower level liberal elective. So that's the second year, and you can see that you're really starting to get into the chemistry in a big way. And those areas that I mentioned, the traditional subdisciplines, you've essentially sampled 4 of those. In third year, so we build on some of the foundations that are established in second year, particularly in analytical chemistry. And we also set the stage for you to specialize and sort of customize your degree a bit. So the fall semester starts with atomic and molecular spectroscopy, which gives you some insights into the sort of spectroscopic tools that we use to characterize molecules and atomic species. And this comes with a full lab. And then also basic chromatography. So this is essentially the chemistry of separating mixtures of things into components and identifying them. And then inorganic chemistry. So this is the first inorganic chemistry course, and this one is looking at the main group of the periodic table, and a math course in probability and statistics, and your first upper level liberal elective. In the winter, you take a course called Characterization of Organic Compounds, where you're now using a lot of the spectroscopy knowledge you picked up in the fall to solve problems where you are given a compound and you don't know what it is, and you have to figure out what it is. And so you use spectroscopic methods to identify what that compound is. And you take inorganic chemistry too, also with a full lab. And this one is focused primarily on the transition metals and their complexes. You take PCS 400 or quantum physics. This is, you could also think of this as quantum chemistry, really. It's it's an understanding of the structure of the atom from the elementary particles on up, using both physics and mathematics to describe. And For the first time now, you see 2 professional electives that you can select. And I'll be talking a bit more about professional electives in just a few minutes, but these are courses that you can pick from a list of courses that are open to you that you can apply towards your degree requirements. And so this is the third year program. In the fourth year, you'll notice that there's not a whole lot of required, specifically required courses. So it starts with an upper level liberal, and then you also have places for 4 professional electives. And in the winter, there is 1 required course, environmental science, and then your third upper level liberal and 3 professional electives. So if you've been keeping track, there's 7 professional electives in fourth year and 2 in third year for a total of 9. So let's talk about the professional electives a bit. So you can choose from 84 courses in a range of sciences. So chemistry, so there's additional chemistry courses you can take, biochem, biology, computer science, communications, math, physics. Now, not all these 84 courses are running every semester. Some of them run once a year, some of them run every other year, and they may or may not fit with your timetable. So there's an element of planning and effort required if you're specific courses you're interested in. That's why, in third year, you might need to think about trying to take those in your professional elective slots. Let's talk about the first set of chemistry courses. So the program requires that you have at least 2 professional electives from this list of courses. So you'll see there's an advanced biochemistry course and there's some other ones, but I want to draw your attention to the 3 that are in the orange box. So these are lab-based courses, which give you an elevated experience of applying your course and the knowledge, your chemistry knowledge, to a research problem. 307 is a research project that's partly supervised by a faculty member and also involves some training. 399 is a lab which is directed towards some kind of a project that you're trying to work through as a group. And CHY 40AB, research project thesis. This is a full year course that involves you doing research in a faculty member's research laboratory on a novel research project. So these are excellent experience for hands-on chemistry. So in terms of how the 83 courses breaks down, you can see here that there's a lot of biology courses you could take. There's 11 additional chemistry courses. There's 21 math courses. So there's a lot of courses to pick from. Why might you in a chemistry program want to take biology courses? Well, that gets us to the next topic, which is minors. So a minor is something that you can apply for before you graduate, and it requires certain combinations of 6 courses. So there's 4 science minors available, 1 in biology to chemistry. So as a chemistry student, you can't do a minor in chemistry, but you can do a minor in biology, computer science, math, or physics. And there's also minors available in other subjects, but the advantages of the science minors are that in the case of biology, you only need to take 3 additional courses to get a biology minor, and for physics, you only need to take 4 more. So you're already getting a head start on those minors. Why might you want to take a minor? Aside from the fact that you might be quite interested in that subject in particular, it also gives you a little bit of a broader degree, and that may be useful for you if you're looking for a job that's kind of at the interface between, say, chemistry and biology. Okay, a few words about the course. So a cooperative program is a program which combines academic study and paid employment. And you apply towards the at the beginning of second year, or maybe even towards the end of first year. It's kind of changing a bit right now, but essentially you get an opportunity to apply, and you need to be performing at a fairly good level in terms of your academic performance. So I would say between a GPA of 2.5 and 3, so around a B or a B minus range. And if you do the co-op program, you'll get a degree which says chemistry cooperative program. It will take you an extra year to complete. The reason why is because in that 5-year period, you're going to do at least 3 work terms. Your first work term is in the summer of year 2, and then there's 2 work terms in the winter and summer of year 3, and 1 in the fall of year 4. You don't have to do all 5 of these, and a lot of students find that work term 1 is particularly challenging because you're in second year, it's the summer, and it's your first work term. It requires persistence, but it can be done. But it's definitely possible to do the 3 work terms, and it's well worth doing because it really gives you experience and sort of a track record and people who can speak to your effectiveness as an employee. Opportunities at Ryerson for students. I'm just going to highlight a few. There's a broad range of opportunities, different kinds of clubs and groups and things. The Science Discovery Zone is an area which allows you to explore ideas. And these could be ideas on the social side, like science literacy and policy leadership, that kind of thing. It could be a more entrepreneurial idea, an idea that you think has potential for development, or it could just be to really explore and understand more about what's, ideas in chemistry that you have. There's also research practicum courses. So these are kind of like volunteering in someone's lab. There's summer research assistantships, which provide you with hands-on opportunities, essentially a summer job, and the thesis course that I've already talked about. And then there's something called Rye-Sci Match, which is a kind of a mentorship program, which allows you to hear from people who've come through our program, or from people who have established themselves as entrepreneurs, or people in industry, people who worked, graduate students, a broad range of people who can provide the insights from their experience and can provide advice. The university supports students in a wide variety of ways. You've probably seen pictures, or you may have seen in real life, our Student Learning Center, which houses quite a range of things, from academic accommodation support to ESL, math support. There's a writing center, career center. We have a student union, which it's based in a different building, financial assistance, and a health center. There's pretty much anything you can think of is available and is deployed to support you as a student. Last thing I'd like to talk about is some of the options that you have after you graduate from chemistry at Ryerson. So the kinds of jobs, and this is a question a lot of people wonder about, is so what kind of a job could I get after graduating from chemistry? So there's research labs in government, academia, or industry, which are looking for people with backgrounds in chemistry. There's testing and analytical type jobs, so in the pharmaceutical industry, analytical services of various kinds, including environmental testing, quality control, product development. Then there's a different sort of slice of jobs in sales and marketing, where a scientific background and an understanding is a big asset. If you're trying to sell a product to scientists, for example, or to doctors, it helps if you yourself can speak their language and you have an understanding. And you can also pursue further educational options, including graduate studies in chemistry, or a professional program, medicine, dentistry, pharmacy, law, or education. There is no hindrance whatsoever to going on to medicine with a chemistry degree background. And this is true for dentistry and pharmacy as well. These programs have prerequisites, and some of the prerequisites that they require are chemistry courses. And if there's biology courses which are prerequisites, so for example, in medicine, physiology would typically be a prerequisite. These are courses you can pick up as professional electives as you go through your degree program. And I think that brings me to the end of this presentation. Hopefully you found it to be somewhat helpful in getting a sense of what the chemistry program is like at Ryerson and the kinds of things you would be doing on a year-by-year basis. I'm around to answer questions until there's no more questions, I guess.
Awesome, sounds good. So what'll happen over the next little bit is I will encourage students who maybe haven't had any of their questions answered, or maybe you have questions about some of the things that have already been spoken about, to feel free to throw those into the Q&A box, and we will do some of these questions live for you right now. I do have one question that sparked my interest near the beginning of your presentation when you mentioned that you do need 2 science requirements, but it's encouraged to take 3. So do you have any advice for some of our grade 12 students who maybe haven't enrolled in all 3 sciences and are kind of maybe like, oh no, I'm a little bit nervous now. If they didn't take all 3 and maybe they are finding it a little bit challenging in their first year, what are some of the supports that we have available for our students?
Okay, so that's an excellent question. So I mean, I guess there's a bunch of different things I could say. The first thing I'll say is you're not alone. I would say a significant percentage of students come in without all 3 courses. So you're not going to be some kind of a freak. In fact, the people who have all 3 sciences are much more unusual than you are. So that's the first thing. You got lots of company. Second thing is, although it does vary, typically most people come in with chemistry and biology, and it's physics that people don't have. So that's sometimes, occasionally, it's chemistry and physics and they don't have biology, but almost everybody comes in with chemistry. So in terms of the supports, so the Faculty of Science runs, so there, for things like math, there's math groups that you can participate in. The other thing, I guess I should have said this a little bit earlier, all 3 of our first year courses, so chemistry, biology, and physics, are all structured and designed on the assumption that you have not necessarily had 12U chemistry. So they're going to start from the perspective of building everything from the ground up. So it's not, the issue isn't that you'll be missing prerequisite knowledge. The only challenge is that because it's a university course, and I mean, this is something, my son has just started first year university, and one of the things that he's kind of really sort of learned, I guess, in the bone is that high school courses seem very leisurely relative to university courses. So things happen super fast in university. You pack a lot into a 12-week period. So it's the pace that's more of the issue. And so that means that if you're taking that course and you don't have that background, you really have to focus on a plan to make sure you're studying and reviewing and so on. And then there's a number of sources which can provide specific help for different subjects. Aside from the course itself, which will usually provide resources, the student unions provide tutorial sessions, and there's also help within the Faculty of Science as well.
Awesome. Thanks so much for clarifying a little bit more about that. I know that's always a worry for a lot of first year students. They want to be as prepared as possible, and it's always good to know that we have supports in place for our students. So I do have some questions as well about our lab spaces. I know that we recently renovated some of them. I was wondering if you could touch a little bit more about kind of like what are students going to expect when they come into some of our laboratories, and some of the new features maybe that we've added, and if there's anything that we've done this year that for our students who maybe aren't physically in the lab spaces, is there anything exciting and fun coming down the pipeline?
Yeah, so, well, it's a crazy time right now. I haven't seen the inside of a lab since March. And I think that would be true for many of our faculty and students as well. So we do have some recently renovated labs. So overall, I'm really happy with the state that our labs are in. So what you can expect in the laboratory course is that you're going to be in a section of about 24 students, somewhere between 20 and 24. It depends a bit on the course. And some of our labs are somewhat open concept in that you may have 2 groups of 24 in a general space. But mostly you'll be working within that group. And Some of the labs you'll be doing by yourself. Some of them you'll be working with a partner on shared equipment. The labs are sort of nominally about 3 hours long. And so you're in there for a period of time. You'll be carrying out an experiment, and then usually you have to write it up and submit it within a week or so. How things are, some of the labs have, so we have quite good equipment, especially analytical equipment that you'll be getting your hands on in third year. And what else? I guess I'll talk a bit about the virtual lab situation right now. So we're the only students who are actually in labs right now are people who are in fourth year doing thesis projects with individual professors, and not all of them are accessing the labs either. They're following strict protocols, et cetera, et cetera. In terms of the undergrad labs, everything's being done virtually, and that's required a lot of innovation and effort to get that up and running. And we're still working on it because we're going into next semester, I think, anticipating that it's probably going to be virtual as well. So in some cases, there's some stuff that's under development that does look pretty exciting. I haven't had a chance to see it myself. I've only heard about it. But I know people are trying to design labs where you're actually using virtual reality to manipulate objects and things. And I would like to see sort of where that's at, but I've seen some sort of initial stuff, and it looks pretty interesting. So I know that's going to carry on regardless of what happens with the pandemic. It's something that people are interested in pursuing.
It's great that you actually mentioned that, because that sets me up to plug another session coming up today, which is medical physics. And they are actually going to be showcasing a virtual reality lab in their session today. So there will be a recorded version of that as well. And I'll definitely pass that along to you, because it looks pretty interesting. And it's great for everyone who's interested in science in general to kind of see where things are going and what you might be able to expect in the next year or two as an undergraduate student, for sure. So that's definitely really interesting and exciting. As you mentioned, some of those labs that are coming through with fourth year students, and some of the labs that you mentioned in your presentation where you have the opportunity to work alongside professors. Do you have any interesting stories about some of the things the students are working on, like some of the projects that they're doing with those professors off the top of your head?
Well, I mean, there's a few that I'm sort of personally familiar with, I guess. We have so the research that gets done in chemistry, there's a very healthy synthetic group. So a group of different faculty members who are interested in making compounds or making materials. So we have an inorganic polymer chemist who's working on making tin polymers, which have a lot of potential because they have semiconducting properties, and in principle you could print them like wires. So you could print these things and they would be conductive. So you could imagine printing circuits, for example, using the same kind of technology that we use to print on pieces of paper. The challenge, though, is that these polymers aren't particularly stable. And so he's been working for a long time, I would say like for the last 10 years or so, on trying to figure out how to stabilize them, with some significant success in recent years. So there's an undergraduate student who's working on one particular aspect of that, which is an idea for a certain kind of monomer that can then be polymerized into a tin polymer. So that's just one example. Somebody else is working on making a molecule which will bind to a specific site in a protein and stick there, and then act like a little sort of sensor for what's happening around it in the molecule that we can probe by looking at how light changes the properties of that molecule.
Awesome. Thanks for using plain language as well. I'm sure there was a lot of words in there that if you added some more oomph to them, I would not know what you're talking about. So as an arts grad myself, I can say that for sure. But it sounds very interesting. It sounds like something that is exciting for students to look forward to as they get into those upper years, and have the ability to work alongside professors as well is something that I know a lot of students aim towards. And so on that note as well too, when we're thinking about and when we're talking with first year students, I myself am a liaison officer, so I typically travel in person, this year of course virtually, to high schools across the province. And some of the questions that come up from students who are looking to go to university is like, how big are class sizes? Am I going to get swallowed up? Am I going to have 1,000 people in a classroom? So I know from my own experience, your first year typically does have some larger class sizes, and it does often get smaller and smaller. But can you speak a little bit to our chemistry program and what they may expect in their first few years?
Yeah, that's great. I'm actually I'm really glad you asked that question, because that's probably something I should have mentioned in my talk. But so, right, as a chemistry student, you will see a range of class sizes. So first year class sizes are not small, that's for sure. When you take first year chemistry, you're taking it with all of the first year biology students, physics students, biomedical science students. So, your class sizes are, I think there's 2 sections, and I think your class sizes are in the neighborhood of around 300 and some odd. So not a small class. And in second year in chemistry, though, you'll notice some changes there. So when you get to second year, the courses that you're taking where only chemistry students are taking, this class size will drop down to about 60. So in analytical chemistry 1 and physical chemistry 1, you're looking at class sizes of between 55 and 65 or 70. The organic chemistry is still huge. And when you get into, by the time you get into sort of fourth year and you're taking those professional electives, it varies a bit, but your class sizes could be quite a bit smaller because not everybody chooses the same professional. So you could be looking at about 20 students in your class. Overall, for chemistry, class sizes are relatively small compared to some programs, for sure.
Awesome, thanks for clarifying. And I know sometimes too, when you think about having, like 300 people in a lecture hall, that can definitely be overwhelming. But I know from my own experience in the Faculty of Arts, our professors were always open door policy, like in their office hours, you can go in and ask questions, you can talk to them and interact with them. And so for the Faculty of Science, and specifically with chemistry, how do you support the students in 300 student lecture halls? Are they still going to get that attention that they're hoping for as well?
Yeah, I think I think we recognize how challenging it is for students in first year in general, because you're making a transition from high school to university, and it's a big step. And you're often in these large classes, and it can feel a bit overwhelming. So, I mean, I think like all of our science courses, we provide, first of all, I mean, generally speaking, faculty like to teach and we like students. And, we wish that we had a smaller class so that we could get to know everybody personally, but we're going to be welcoming and warm to people who want to reach out to us and talk to us. And secondly, because of the sheer numbers of students, professors will have TAs as well who are available to help students and answer questions as well. So those are some of the resources that get deployed. And we also make a real effort in those courses to try to give people chances to get feedback. So, I mean, I believe all of our first year courses use interactive technology so that students can answer questions in class and get immediate feedback as to whether they've answered correctly or not, things like that. Of course, it's a whole different story in virtual education. I could be teaching a class of 300 or I could be teaching a class of 10, but when I'm teaching, all I see is me. But I'm looking forward to the day when we can get back and actually physically see each other.
For sure, I know I'm definitely craving that, the reactions and the experience with the human connection for sure. And good news is that as things progress, we're going to keep getting more innovative with our technology in the virtual aspect. So it's a transition for sure, and it's not something that you normally have to do on the fly. But I think that everyone's doing their best, and so far it seems like a lot of our students are very successful and happy with how things are going. So that's great to hear. Now I know that you have, like you mentioned, a son who's in first year this year. And, sometimes even for me, when I was going into my undergrad, it's like, you're making a very big decision at a young age. What happens with some students, and I'm as a program director, if this is out of your scope, just let me know. But as students go into first year and they're taking things in biology and medical or in physics and chemistry, what happens to some students who maybe think, you know what, maybe I'm in the wrong program? How is there a transition period where they can potentially transfer? Can you touch on any of that information?
Yeah, absolutely. So one of the reasons why we have a nearly common first year for chemistry, biology, medical physics, and biomedical sciences is to make it easier to potentially switch your degree program or your degree plan if you need to. So let's talk about that. So basically, the common science programs, chemistry, biology, and biomedical physics, you can very easily switch between those because we call that an academic plan. So everybody's in the same degree program, but they have a different academic plan or major. So it's very easy after first year, but before second year, it's very easy to switch back and forth between those. Biomedical sciences is a bit more challenging because it's configured as a separate program. So that means you have to apply to that program kind of the same way that you apply when you first start. So it's not a simple plan change. It's a little bit more difficult, but I mean, you have all of the prerequisites in first year, except for one course that you can pick up later. So that's not a big deal. After second year, it gets a little bit more difficult. It's certainly not impossible, and people do it. It usually adds a bit of extra time to your degree completion, but up until the end of first year, it's pretty straightforward.
Awesome. Thanks for mentioning that as well. I know as students, get into their second, third, fourth year, they're looking for something to do in the future. Like we're not just going into university to get a degree anymore. A lot of students want to get a degree that they can get a job in. And I know that's why our co-op programs are so sought after, and that's something that we like to highlight a lot. And I know that you've already mentioned some co-ops. I'm curious if you could talk a little bit about some of the things that our students are doing in these co-ops, like some of the positions that they're getting. So then that way it can give students an idea of where they can kind of strive for or what they can strive for after they graduate as well.
Yeah, so I mean, the co-op positions tend to be what I would call sort of entry-level lab positions. So you're doing it's often a bit mechanical or a bit repetitive, but you're doing sometimes testing, sometimes formulation of materials. So we've had a couple of people recently who are adventurous who are working in the oil industry out west. Actually, I mean, most people don't move to do a co-op position, but a couple of people I know did, and so they were doing testing of petroleum samples for certain characteristics like viscosity and so on that the manufacturer wanted to optimize for. So they were providing service in that way. There's a variety of possible types of jobs that you can do, but they typically involve sort of entry-level lab type jobs. I should say too that there's also, even people who aren't in the co-op program, there's lots of opportunities to get practical experience. And as a student, you've got to basically, it's something that you need to sort of prioritize. So some of the things that I talked about, like the Ryerson match program, the science discovery zone, seeing if there's volunteer opportunities by taking I'm not going to remember. Anyway, by taking, I can't think of the name. That's obviously a senior moment for me. Or the thesis course and some of those things where you get some research experience. The key thing is that somebody can evaluate you and say, look, I had this person and they were good and here's what they did. I would recommend that you consider them. That makes such a big difference in terms of trying to get a job when you have somebody who can write a letter of recommendation for you based on what you've done in a lab.
Absolutely. That's a really good point about, finding the opportunities to get those experiences on campus as well, and not just in co-op, but, add as much as you can to your resume before you graduate. And that'll definitely help in terms of finding those positions. We did actually have a follow-up question from when we were talking about the switching programs potentially. So we did have someone who asked, what year will you recommend to make the switch? Would it be like after first year or during first year? Kind of, like when is the best time then to kind of, not with going into the intention of finding a time to switch out, but just, so then that way we kind of have a more understanding. Yeah.
Yeah. I mean, I guess at the end of the first semester, first year, if you know for a fact that you don't want to be in that program, then that would be the time. I don't think there's much point in doing it before you finish one semester. But after one semester or after first year, I think once second year gets started, like if you compare the programs, you got a pretty good look at the chemistry program here. But if you were to compare it with the biology program or medical physics, you would see that in second year, there's not a lot of overlap in terms of the courses. Like the biology students take organic chemistry, but they also take microbiology and I forget what other biology they take, but they start taking a lot of biology courses the same way the chemistry students are taking a lot of chemistry. So it gets harder to do the switch, but it's not impossible because, for example, after say the first semester of second year, you've taken a bunch of biology courses, you've taken a bunch of chemistry courses, but you want to go into biology, you can use those chemistry courses as professional electives in the biology program. The main issue is just it gets harder to schedule your courses so that you don't have conflicts and things until you get back into what we call back into phase. I think after second year, it's never too late, but it's kind of late after second year. So I think just because it's gonna take you longer to graduate, so you're going to be spending more money on tuition and courses and things like that. Nobody wants to do that. So I think sometime between after the first semester and say before at the end of first year or possibly as late as halfway through second year, but I wouldn't recommend waiting much longer than that.
Awesome, thanks for clarifying. So I do have one more question on my list of questions, and then of course, if you have any further, feel free to throw them in the Q&A chat. We still have about 13 minutes left for the rest of the hour. But my last question, and I know that you've already touched on a little bit about students who are looking to go into med school or pharmaceuticals, or that's kind of a typical question I know I get a lot from students in grade 12 who have these ambitions of going to med school, etc. Each med school is going to have their own prerequisites, and so we always recommend for students to look at the med school that you want to go to, so then that way you are setting yourself up to apply for that school. But do you have any advice for students who are pursuing this, who are thinking about this? Chemistry obviously is something that does set you up for that, but do you have any advice for some students who have this as their goal in life?
Yeah, so I would say that is sort of the number one question that you get, right? When we've had the university fair, that's a question I spend a lot of time answering. So I can definitely give you some thoughts. So, I mean, I guess the first thing is you absolutely have to look at the professional schools that you're interested in and make absolutely sure, like Jess said, you have to make absolutely sure that, because they're the ones who determine what the prerequisites are. And there are differences between them. Secondly, what should you be thinking about? Well, you should understand what enterprise you're embarking on. And that there's two ways in which, so the first thing is, it's incredibly competitive to get into these schools. Like these are not easy to get into. So you have to be performing at a high level and you have to be focused and really know that this is what you want to do. Having said that, you need a plan for how you're going to pick up these courses. So for medical school, for chemistry, I think you've got almost all of the courses that you would typically need, but there may be a biology course like physiology that you need to pick up. So you kind of need a plan. I guess the second thing I'd say, it's just more of a philosophical point, is a lot of people maybe they think about it, what a great career, and they think about like, oh, I'd be making lots of money and I'll have all this status and so on, but they don't necessarily think about what they're actually going to be doing. So, I mean, I think a first question you should ask yourself is, am I actually interested in medicine? Like, am I interested in the human body and how it works and, diseases and illnesses and stuff? Is that something that actually interests me? Or am I really just interested in this because I like people calling me a doctor? Because there's other ways you can get people to call you a doctor. But the other thing is that, you know, how do you feel about using your hands? How do you feel about dealing with people who are in pain? You know, and this is very relevant to dentistry. You know, so people think it'd be great to be a dentist, but they don't necessarily think about what it's like to be a dentist. So I guess the thing I'd say is, you know, I'm not trying to discourage anybody, but I would say, you know, do some research, you know, talk to people who are in these fields, find out what they do, and, you know, ask yourself, am I genuinely interested in this? Because you won't succeed if you're not interested. Like, you know, if you don't like dealing with people who are sick, it's not going to be a good career for you to be a doctor.
Well, that's some really great advice. So thank you so much for sharing that. We are getting a little bit quiet in the Q&A box right now, and we are 10 minutes to the end of the hour. So I think what we're going to be doing now is we are going to shut down our cameras and mute our microphones, but we will stay online for the next 9 minutes. So you'll see the screen shared still with questions, like the screen that, sorry, the PowerPoint that's still on your screen will stay there. But like I said, we will kind of shut down and we will be here for the next few minutes. So if you have any last second questions that you think of, please feel free to throw them in the Q&A chat and we will get to them as soon as possible. We would like to thank everyone so much for joining us. And of course, our presenter, Dr. Stephen Wiley, for joining us today too and taking time out of his day to be here with us and answer some of these really great questions as well too. Please feel free to take a look at our website. If there's any other sessions that are of interest to you, feel free to register for them and come in and join us for the remainder of the day if you have some time in your schedule. And of course, like I mentioned, medical physics coming up soon has that virtual reality lab. So if you're interested in just kind of seeing what it might be like, feel free to come join us for that. And hopefully we can give you some really great information in those sessions as well. So on behalf of Ryerson University, thank you again so much for joining us, and we hope to see you in more sessions throughout the next week or so as well too.
Yeah, thanks everybody.